Hello everyone. Today we're going to go through section 3.5, going through the notes about finding slopes and y-intercepts. So we are on page 79 in your student journal. These notes are going to be rather brief, straight to the point, as this information should be already in your brain. We're just taking it a little further today. So if you remember our equation, y equals mx plus b. That's our basic equation that we're working with. So the first thing is m. That's our slope. So that is going to be a good thing to remember. And then our b, that is our y-intercept. So by having an equation and being able to identify those two pieces, that's what's going to help you through these next few sections. So we have our equation for problem A. Y equals 2/3 x plus 2. So remember, our starting equation is y equals mx plus b. Well, to find our slope, you look directly below. That's the number or the coefficient that is attached to x. So for this one, our slope, which is also just m, is 2/3. And our y-intercept, that's the number that's directly below b. I'm just going to abbreviate. For this one would be 2. And that's all you have to do, is look at the equation and be able to identify those two pieces. Let's try the next one. So we have y equals negative 2x minus 1. So again, I'm just writing my y equals mx plus b equation over top, so I can always have something to refer to. So my m, or my slope, for this one is negative 2. And my b, so be careful. The plus sign disappeared. It's technically still there, even though you don't see it. So our y-intercept is in fact negative 1. And on this one, you can easily go back and check your work by looking at the graph. So this would be our y-intercept, which is negative 1. Our slope is negative 2, which means we have a rise of 2 and a run of 1. And if that works out, that means we did it correct. So the big thing I want to point out between A and B, our slope for A was positive. Our slope for B was negative. Our positive one went up. Our negative one went down. So whenever it comes to graphing and you're not sure which direction your line is going to go, look at your slope. That tells you if you're going up or down. Okay, now we're moving on to the next section. So they've already done the first one for you. We have y equals negative 2/3 x plus 3. The description of the graph is a line. They found the slope, they found the y-intercept. The reason why this one is a line is because of our x. Because the x does not have any exponents on it, it means it's going to create a straight line. So that means for all of these ones, we're going to create straight lines. So I'm going to do this first one with you and then pause, and so you can do C and D on your own. So our slope for B is 2, and our y-intercept is negative 2. So pause here so you can do C and D on your own. If you're just joining us back, we found that on C, our slope is negative 1, the y-intercept is positive 1. And for D, our slope is 1 and our y-intercept is negative 4. If you weren't sure what the slopes were going to be on C and D, remember, if there's not a number written in front of our variable, it's that invisible 1. And that's how I know my slope is going to be -1 and then +1. Okay, moving on. Now we're taking those equations and we're going to put them on a graph. So we have y equals -2/3 x plus 3. So I'm just writing it down so I can zoom in and see it a little bit more clearly. So remember this right here, that's my slope. And this is my y-intercept. Whenever I'm putting something on a graph, my starting point is always my y-intercept. If I have it, I'm going to put it on there because that way I know where to start from. Now, my slope, it's negative, so that means I'm going down. So this, and if you're given a fraction, it's actually really helpful because it tells you the rise over the run. And our rise is actually going down on this one because it's negative. So we go down 2 over 3. There's a point for our graph. Down 2 over 3. It's off our graph, but that's okay. And I'm going to do one more up here. And so this time I'm going to go in the opposite order. So I'm going to run 3. And I'm going to rise 2, just so I can have one extra point on my graph. Now this is where I can connect all my points and make a nice straight line. And there you have it. That's what your graph should look like. If I'm ever going too fast, you can always pause, rewind, do what works best for you. But I'm going to move on to B. I'll do B with you, and then you'll do C and D on your own. So again, I'm going to write down my equation. So y equals 2x minus 2. And so, sorry if you hear some barking in the background. First thing I always do is I put my y-intercept on my graph. There it is. Now my slope, this time it's positive, so it's going up. Well, unlike the last one, this isn't a fraction. But if it's a whole number, it's really easy to make into a fraction. We put it over 1. So rise and run. So I'm going to rise 2, run 1. Rise 2, run 1. And so now from here, I'm going to go ahead and create my straight line. And there you have it. Done. So pause here so you can do C and D on your own. So if you're just joining me back, that's what your graph should look like for C and D. As you can see, they're very similar. It's just a small little staircase that you make every time. One's positive, one's negative. So the big things to point out on this, the M, that's our slope. Slope controls the steepness and the direction. If it's positive, it goes up. If it's negative, it goes down. The bigger the number, the steeper it is. The smaller the number, the smaller it is. B, that's our y-intercept. That's our starting point. That is what is telling us where we're going to begin our graph, and that helps us create the graph with ease. So now some key things to point out. This is the biggest takeaways from our notes today. Positive slope, so that means our M is a positive number, we're going up. A negative slope, that means our line is going down. a slope of 0. So that would be an equation that looks like y equals 2. It's a straight line that goes across. It's not going to vary up and down at all. It just stays flat. And then lastly, we have undefined slope, which is when our graph is going straight up and down. If we were to do that vertical line test we did forever ago, it would fail because it would all fail. Everything would go through. Whereas on the rest of these, only one point ever goes through them. So stay tuned for Mr. Patinsky's video and go through the extra practice problems.